Hello everyone. In this lecture, we will discuss some numerical problem related to specific heat from the point of view of examination. Okay. So if you get the theory, so first one is if density of aluminium is 6.02 into 10 to the power 28 per meter cube, velocity of longitudinal wave is 6374 meter per second, and that of transverse wave it is given as 311 meter per second. Okay, find divide frequency and temperature. Okay, so you first look out. So what are the given quantity? Density. So density means number of atoms per unit volume. So it is given 10 to the power 28. All you first to take care of all the units. This is very important. CGS, SI you should not mix up. So actually here all are in. So VL longitudinal is 6374 and VT is 311. Okay. So these three answers given. You have to find theta D and nu D, divide frequency. So you know what is divide frequency cube formula. We have divide frequency cube formula 9n by 4 pi b 1 by BL plus 1 by Vt. So it will be cube okay, minus 1 inverse. So now you just substitute all values. So n by b, this is already given, so you put 9 into 6.02 into 10 to the power 28 by 4 pi, so 1 by 6374, this is transverse cube, sorry it is longitudinal, transverse is 1 by 3111 1 cube minus 1. So you calculate and you will find that divide frequency, you find divide, and 1/3 you put it 1/3, it will be 8.5 into 10 to the power 12 hertz. So this is the first and very easy. Theta D is h nu d by k. This already you know. Once you find divide frequency, it is very easy. So 6.62 into 10 to the power minus 34 joule per second into 8.5 into 10 to the power 12. This already you find from this. And you find put k 1.10 into 10 to the power minus 23 joule per Kelvin. It is joule second. It is joule per Kelvin. It is hertz. So ultimately it will be 433 Kelvin. So this is divide frequency. This is divide temperature. This is divide frequency. You should remember here we have cube. Okay. So even if sometimes we might have missed this cube factor in our earlier calculations, but it should be cube. Okay. You should remember that this one. Okay. So this is one of the questions. Now very easy. Now we move to the second question. Second question is divide temperature is 400 Kelvin for aluminium. Okay. Find specific heat at constant volume at 45 Kelvin. So solution, you see here what is given, only divide temperature means theta D is given 400 Kelvin and you are asked to find T is given 45 Kelvin. You are asked to find Cb equal to what. Now one of the important thing concept that I have mentioned, that when if you use general equation of Cb, you cannot find this. Here some assumption or some tricks is required. You see divide temperature is 400 Kelvin and temperature is 45, so almost 1/10. So we know at low temperature we have T cube law for T less than theta D by 10 almost. So we will use the low temperature formula. So what was the low temperature formula? It was very easy. 12 by 5 pi to the power 4 r like that. So it was 12 by 5 pi to the power 4 r d by theta d whole cube. Rest of the things you can easily do. You put 12 by 5 by pi to the power 4 12 5 pi to the power 4, it will be this factor. Actually all these things comes out to be 77.9. This is fixed value. Into R is 8.31 joule per mole, and this is 45 by 400 cube, so you find it will be 2.765. so you have to find specific heat joule per Kelvin per mole. Okay, so this will be very easy. This is 2 mark question, but you have to understand that you have to use the low temperature formula. This is very important, because you see Debye temperature and temperature that you are asked almost 110, so it is very low temperature compared to Debye temperature. So Debye T cube law we have to use here. Normal Debye frequency, Debye temperature. Okay, now we move to another equation for finding this will be related to the finding Einstein temperature. One numerical we will do, very easy. Numerical number 3, with direct formula. Calculate CB for a material. Lot of numerical you will also get in the textbook, so I am just copying from the textbook, but just for your reference I am putting this. So for material at 100 Kelvin, you have to find CB at 100 Kelvin if Einstein temperature, means theta E is given as 157 Kelvin. Einstein temperature is given, find also Einstein frequency. Temperature is given but frequency is not given, so you have to find Einstein frequency. What is Einstein frequency? Nu E equal to H Einstein temperature is theta E equal to H nu E by K. This you know, theta E H nu E by K. So you have to find nu E. So nu E equal to K theta E by H. So you just substitute K. What is K? 1.38 into 10 to the power minus 23 by H 6.62 into 10 to the power minus 34. Okay, so you put theta E 157. So all this will come out in terms of hertz, so you have to put in terms of hertz. So it is almost gigahertz. 10 to the power 12 means almost gigahertz order. Okay, so Einstein frequency you have to find. It's a very easy formula. We know this Einstein temperature is nu by E by K. Okay, now the second part, or actually the first part, CB. So what is the formula for CB? CB was 3 and K, or 3 R theta E by T whole square. Here square law you should remember. Here it is square law, very easy to remember. E to the power theta E by theta E by T minus 1 whole square. This was the CB expression at any normal temperature. It is not low temperature expression, it is at any temperature. Okay, it is at any temperature. So now you substitute these values, of CB. So you just substitute this value, 3 into 8.31 into 157 by 100 square to the power 157 by 100, 157 by 100 minus 1 square. So with numerical you find 3.8 joule per Kelvin per mole. Okay, so this is CB. So this is very easy. So this type of question may be asked in the exam, finding CB, characteristic temperature, Einstein temperature, Debye temperature, Debye frequency. So these are the general formula. If you remember, you can very easily you can solve this. Okay, so you can try one more example also. Okay, this you try as a homework. If Einstein frequency is 7100 gigahertz, you should remember 7100 gigahertz means 7100 into 10 to the power 9 hertz. Actually this is terahertz. Tera means 10 to the power 12, and if it is giga, it is 10 to the power 9. Okay, so you should remember this is terahertz. Earlier I have mentioned wrongly giga, it is actually terahertz. Okay, so terahertz, gigahertz. So 10 to the power 9 is a gigahertz, it is given. Okay, find Einstein characteristic temperature, means you find theta E equal to what you find, and find CB, molar specific heat at T equal to 100 Kelvin, 600 Kelvin and 800 Kelvin. You are asked to find CB at this temperature. So this is 3R theta. So theta E is not known, so you find theta E by this formula, very simple. And find 3r theta, you put all this, you find Cb. So here will be Cb at 100, Cb at 600 and Cb at 800. Okay, 3 values will be there. So question is, when you get Dulong petite law. So obviously we know Dulong petite high temperature, so obviously as a common sense it will come around 800 Kelvin. So you just do, this is a homework assignment you can do. So this type of numerical are asked in the exam. পরীক্ষাতে কিন্তু আসে এইভাবে ডিভাইড ফ্রিকোয়েন্সি, ট্রান্সভার্স ভেলোসিটি, লঙ্গিটিউডাল ভেলোসিটি। অনেক সময় যদি ট্রান্সভার্স আর লঙ্গিটিউডাল ভেলোসিটি দেওয়া না থাকে, you should take both equal to velocity of sound. Sometimes you have to consider this equal to velocity of sound in the solid. Okay, you can take sometimes that value also. And also, okay, so this you can do this type of numericals. You try from the textbook. There are many lot of exercise questions are there, so you can try. So okay, here we conclude the part of specific heat of solids. So here actually we have many lectures on this, because one lecture will get lengthier, so I have split it into multiple lectures. You review or revise all the lectures. First is the classical theory, then is Einstein theory, then is the divide theory, and then comparison and some numerical. Okay, so this will conclude the specific heat of solids. In the next lectures we will be going to the free electron theory, some basic idea of drift velocity, mobility. Already we know the definitions. Again we will try to revise the definitions. We will see some formulas and all these things. Free electron theory, drift velocity, mobility, like this. Okay, we will derive some formula, and from that we will find thermal conductivity, electrical conductivity, and Weidmann-Franz law. Some question may be asked from that part also. So we will do that in the upcoming lectures. Okay, thank you.